Crossing the Rio Grande River at Eagle Pass, Texas, the Camino Real International Bridge is emerging as a critical commercial thoroughfare between the U.S. and Mexico and a potential target for border crime. Now a team of nearly a dozen UC San Diego researchers have successfully deployed a prototype high-tech video surveillance system to help police in the tiny town of Eagle Pass monitor vehicular and human traffic under and around the busy toll bridge.
The first time I heard about the need at Eagle Pass was in February 2005.
Less than 18 months later, UCSD electrical engineering professor Mohan Trivedi joined Eagle Pass Mayor Chad Foster and other officials at a news conference in Texas to unveil the prototype system called Eagle Eyes, the first of its kind in operation.
It's really an experimental test bed for doing more research also, but it is an operational, useful system for people to use it from today onwards.
Eagle Pass has been highlighted for many years as a major crossing point for illegal trafficking of narcotics and human traffic, and we want to make this particular area of Texas a safe haven for our citizens, and certainly national security is an issue of great concern for us.
One of our greatest concerns was what can happen under this bridge. Border Patrol is doing a tremendous job, but this will just add an additional facet to help protect Eagle Pass and the border.
The Eagle Eyes system grew out of work Trivedi and his computer vision and robotics research group were doing at UCSD in the wake of 9/11. They are among the first to adapt machine vision technologies for counterterrorism surveillance with funding from the Federal Interagency Technical Support Working Group, TISWIG for short.
After the 9/11 tragedy, TISWIG was given a lot of Department of Defense money to try to look at some innovative technologies from the non-big DoD type applications. And we published a broad agency announcement and received thousands of good ideas.
Over 12,000 applications were submitted, only 47 funded, and the UC San Diego proposal to develop advanced distributed interactive video arrays for safety and security was one of only 8 in the area of surveillance technologies getting the green light. Trivedi says these are full-fledged systems.
Camera is a part of it, computers is another part of it, communication, how do you take things to cooperate between themselves or cooperate with operator which is half a mile away or half a world apart, and then how much of involvement of a human operator is required to look at all these cameras is also a research issue.
Trivedi's work later caught the attention of Chris Aldridge, director of a National Institute of Justice program called the Border Research and Technology Center based in San Diego. Aldridge was looking for solutions to Eagle Pass's bridge surveillance challenge. That challenge, existing border cameras provided coverage of the bridge's surface, leaving large areas below and near the bridge uncovered.
The problem that Eagle Pass identified was the need to obtain some type of a picture of what was going on underneath the bridges that went across the Rio Grande River. So there had to be an innovative solution identified and applied, and that again led us to Dr. Trivedi's work and his project in using 360 degrees video surveillance in the context of some other camera configurations to give them that sort of public safety picture that they really needed.
That technology is one of the critical components integrated into the Eagle Eye system, which includes 3 cameras distributed underneath the Camino Real Bridge. On the riverside near Mexico, a pan-tilt zoom camera is equipped with near-infrared illuminators providing high-resolution 24/7 surveillance of dimly lit regions, even in the pitch darkness of night. 400 feet away, roadside, an omnidirectional 360-degree camera provides a panoramic view of the entire bridge as well as nearby roads and riverbanks, and another pan-tilt zoom camera is integrated in the system that allows event-driven servoing. Servoing is a well-established robot control technique using vision in feedback control loops, and an anomalous event perceived on the Omnivision camera can then trigger a move by the companion camera to pan, tilt, or zoom in on an area where the event appears to be happening for a clearer close-up picture.
It is like human beings that the panoramic vision is providing us peripheral vision, but then if you want to home in on something which is interesting at certain spot, then the foveated vision, so to say, can be realized by this pan-tilt zoom controllable camera. So that unison operation, how do you make it work, has been one of the research areas that we do.
Eagle Eyes runs with Trivedi's custom software, which helps capture, analyze, encrypt, transmit, and display video. All three cameras stream video simultaneously to a control room in the nearby Eagle Pass Customs building via both secure wireless connections and wired landlines. Police interact with the video through an intuitive map-based user interface. They can control the cameras and use a joystick to focus on objects of interest.
If I'm seeing some activity under the bridge, I can zoom in on some license plates on the car, or I can zoom in on a person's face and I can get a still image of it. That's going to let us know of activity that's happening on the bridge, whereas we don't have to send anybody just to patrol or depend on somebody to call us. We can see it in time, and at the same time, with the still images that we can photograph, that's going to help us to provide evidence in case we do catch somebody.
Because these are distributed cameras, like human binocular eyes are distributed, the advantage is that if we can get them calibrated and triangulated properly, then we can actually realize the depth perspective also.
Now that the UCSD team has deployed the first generation of Eagle Eyes, they are busy in their California lab working on next steps, including automatic 24/7 situational awareness of a scene.
That there's so many events that will be happening during the daytime, nighttime, and in so many locations that we can't possibly cover them all with people watching the cameras and controlling it themselves. So we want the machine to be able to learn what events that are going on in the scene are the abnormal and dangerous events and try to identify those events. And this is the sort of research that's moving forward from the Eagle Eyes project.
I'd like to see more pilot projects in other areas, that apply this technology to solving real problems out there in the security area.
The work on Eagle Eyes was funded by TSWIG with supplemental funding from the Department of Homeland Security. The National Science Foundation is funding UCSD's Trivedi to work on related technologies. The Rescue Project, for instance, led by the California Institute for Telecommunications and Information Technology, is investigating the use of Eagle Eyes type systems to support enhanced situational awareness for first responders in the wake of an emergency or natural disaster. A two-camera version was deployed in late August during a San Diego County disaster preparedness exercise at UCSD. The NSF is also funding a large bridge information technology research program. For that, Trivedi's team is investigating the use of remote sensors to learn dynamic patterns associated with the structural health and traffic conditions around a bridge, specifically multimodal sensing, so not just cameras, but seismic and acoustic sensors as well. A prototype sensor network has already been deployed on a UCSD campus bridge spanning Interstate 5.
Robustness to environmental conditions, so it goes 24/7 and long term, was one of the defining criteria in this particular project. And the second one was ability to scale up. So we really believe that the way this is structured, where we have got wireless connectivity as well as wired connectivity, allows us to really, on hours notices, start adding additional nodes.
I think this is one of the few, if not the only, test bed where a university has actually deployed it to a real security environment, outdoors. You've seen the wiring, the applications, the redundancy they had to put in. That's a great success story, not only for the university, but for the way the governments work, the way we use the taxpayers' funds. And I hope that UCSD will continue to be interested in this kind of work.
I personally would like to see this thing stay in place for a few years. So it allows us a very unique opportunity to observe with this distributed interactive video arrays real-world conditions in something which is of national, international, local significance. Safe driving.